Hey everybody, Mr. Sewell here with your instructional video on how to use a dew point chart and a humidity chart to calculate either dew points or humidities. So, I want you to follow along with me here. This is the dew point and humidity activity. You can find this on our haiku page. This is on Wednesday, March 24th activity. This is an early release activity, so for you cohort A and remote students, you'll need this video to be able to answer or to be able to perform this particular activity. All right, so it's pretty simple. These numbers, you've got called the wet bulb and the dry bulb. What they're referring to is a device called a sling psychrometer, and basically it's two thermometers, except one of them has a little wet sock, a little piece of cotton wrapped around the bulb, and what you did is you slung them around in the air. And the one with the wet bulb or the little sock on it, it would evaporate water off of it. And the lower the humidity in the atmosphere, the more water would evaporate. And anytime water evaporates, that pulls heat out of something. So what happens is you would get a temperature difference. You'd have a dry thermometer and a wet thermometer. And whatever the temperature difference was, you could calculate the humidity in the atmosphere. And so that's where the term wet bulb and dry bulb come from. If you have questions about it, you can do a search for a sling psychrometer, and it's P-S-Y-C-H-R-O-M-E-T-E-R, spelled with a P. But you can do a search online and look up a sling psychrometer and watch how they operate. But anyway, you're given the air temperature, which is going to be your dry bulb temperature. And then you're given the wet bulb temperature. You can see that the wet bulb temperature is going to be slightly depressed from the dry bulb, which means that there's a humidity difference. All right, so all you got to do is subtract these two temperatures. And so if I subtract 18 from 13, I'm going to get 5. So I type 5 in there. And then I go over to my dew point chart. Okay, so I'm switching screens on you here, but you'll notice that the dew point chart here, and this is on the third page of your lab. You've got a dew point chart and a humidity chart, so we want to make sure that we're on the dew point chart. But you'll see it says difference between wet bulb and dry bulb temperatures. Well, we calculated that to be 5 degrees. So I'm going to go over to 0, 1, 2, 3, 4, 5. So my dew point is somewhere in this column. But look at the title over here. It says dry bulb temperature. Well, my dry bulb temperature on my lab was 18 degrees. So I go down to 18 and over to 5. And where those two meet is right there. My dew point temperature is 9 degrees. And so I'm going to go back over here and type in 9. All right, I'm going to do one more with you, then I'll do one of the humidity charts. You do the humidity, the same thing. You just got to make sure that you're on the humidity chart. So, my dry bulb is 28 degrees. My wet bulb is 26. I subtract them, and I'm going to get 2. Okay, I'm back over to my dew point chart, and I'm calculating dew point here. So, my dry bulb was 28 degrees. That's way down here. My difference between them is 2 degrees, and so that's this one right here. So my dew point is 25. Now the dew point is the temperature at which dew will form on the grass, trees, cars, whatever. So it describes when the air becomes totally saturated or it has 100% humidity of water. And so typically your dew point temperature is going to be early in the morning. Sometimes it can be right after midnight or 1 o'clock. Sometimes, depending on how humid the air is, it may even be before midnight. But usually you need that cooling effect to take place. And so as the air cools, the air shrinks. You can, as the air shrinks, it's going to get more and more humid. All right, so that's what the dew point chart is telling us. So let's go over back to our lab here, and let's do a humidity activity. Let's see if we can't calculate the amount of water that's in the air or the humidity. Humidity is nothing but a percentage. It's the percentage of how much water is in the air based upon how much water the air could hold. So if you had a glass of water or a bottle of water that was half full, you'd say it's 50% full. Well, think of that as humidity. 50% humidity means the air is half full of water. 75% humidity is 3/4 of the way full of water. All right, so you do it the exact same way. You subtract your dry temperature or your air temperature, which is your dry bulb, from your wet bulb temperature. So 24 minus 16 is going to be 8. This time, when I go, this time instead of using the dew point chart, I'm going to make sure that I'm on the relative humidity chart. So my numbers are slightly different. All right, so my dry bulb temperature, I go down and find my dry bulb temperature. That's 24 degrees, which is right there. So it's in that row somewhere. And then my difference between wet bulb and dry bulb was 8 degrees. So I'm going to come over here to 8. I go down, and wherever the row of 24 and 8 cross, that's going to be my relative humidity. And you can see that that's 42. Move back to my lab here, and then I type in 42. So if the air temperature is 24 degrees Celsius, which is about 78, 80 degrees, somewhere in there, and your wet bulb temperature is 16 degrees, that's a pretty big difference as far as temperature goes. 8 degrees is a pretty big difference when it comes to doing these sling psychrometers. So you get an 8-degree depression or 8-degree difference. So that tells me that the humidity is pretty low. So 42% humidity is pretty low. All right, so it's in other words, it's pretty dry air. Okay, so that's how you do that. The other chart is the other activity is you're just interpreting this graph. You've got the triangles. The line with triangles on it is humidity. The line with a dark circle is air temperature, and the open circle is dew point temperatures. And you're just trying to figure out, what time of day is certain things happening. Like the highest temperature would be, the highest humidity here is at, let's see, each line is going to be worth 2, so that's at 6 o'clock. All right, the lowest humidity would be down here, and that's 12 o'clock. See, 12, that'd be 2 o'clock right there. All right, so that's all you're doing is just interpreting this graph. Okay, let me know if you have any questions, and I'll see you. Have a great rest of your week. Don't forget to get everything done, and be sure that you're signing on each day. Even though you're not here, sign on each day so I can count your attendance. Okay, see you.